ठीक है, so I said not only boil and melt.
Yeah.
ठीक है, let's add melt to it. So pure substances, they boil and they evaporate and they melt, not evaporation, at a very specific temperature. So for example, you have water. Water has a melting point. I'm going to write MP and BP, which is boiling point. So water has a melting point of 0 degree centigrade. The melting point and
Yeah.
the freezing point are the same thing.
Yeah.
And water has a boiling point of 100 degrees centigrade exactly. Okay, so
Yeah.
that's water. Between the 2 points, it's a liquid.
Yeah.
Beyond the boiling point, it's in gaseous states, it's in steam, it's water vapors, and below that, it's ice.
Yeah.
Okay, so the three states in which water exists.
Mm.
And you also need to remember that if you add salt to water,
Yeah.
so and let's talk about adding any salt. So if you add salt to water, what happens is that the boiling point increases
Okay.
and the melting point it actually
Decreases.
decreases,
Yeah.
which basically means it actually becomes easier to melt it. Okay, it becomes a lot easier to melt it
Yeah.
and kind of difficult to actually boil it. So
Okay.
melting actually happens much easier, and
Yeah.
this is why in colder countries, I don't know if this happens where you live, but in much colder countries like Canada, they have a lot of ice on the roads. So what they
Yeah.
do is they add salt to it.
Yeah. Yeah.
So in some countries, as in some countries, salt is sprayed on roads to prevent ice formation. I said to prevent, in some countries, salt is sprayed on roads to prevent ice formation because the melting point decreases.
Yeah.
So that means it's actually now easier to melt it. Okay,
Mm.
if it were melting at 0 degrees centigrade, now it can melt at -3 degrees centigrade. So even at
Yeah.
-3 degrees centigrade, you can melt it. So
Okay.
that is one advantage of adding salt to water. So remember this as well. This is about water. I said lots of things that we're going to study would be about water
Yeah.
because it's everything on planet Earth revolves around
Needs
water.
water.
ठीक
Yeah.
revolves.
Okay.
I mean, we are made up. I mean, our main solvent is water. ठीक Our blood is
Yeah.
mostly water. Our cells are mostly full of water. So all the chemistry that's happening around you, that's primarily based on water, which is why we're going to
Okay.
discuss water a lot.
Okay.
Uh, on some other planet, some other substance or compound would be more important compared to water. As I saw this one, adding salt to water, this happens. I said then there's another thing about boiling and melting points, and that is predicting the state of a substance. So how do you actually predict states? With states, I mean the solid, liquid, and gas part. That if it's a solid or a liquid or a gas. So a few quickly. I mean, we'll talk about
Mm.
water first because you already know about water.
Mm.
What is water at 150 degrees centigrade?
Is a gas.
Okay, so you know it's going to be water would be in gaseous state. It would be in steam. What's water at let's say 80 degrees centigrade?
A liquid.
Okay, and so that's a liquid. And what is water at -5 degrees centigrade?
Solid.
Okay, so you pretty much know everything about water. You know
Yeah.
what this because you know that water has a boiling point of 100 and a melting point of 0.
Yeah.
So you're already familiar with that.
Yeah.
And how did you actually predict it? Because you had the melting point of water, which was 0,
And the boiling point,
and you knew the boiling point of water, which was
100.
100. Okay, so you used these two. This is not the boiling point. This is the melting point, and this one over here is the
Melting, boiling point.
boiling
Yeah.
point. Acha, so you use these two values.
Yeah.
Now, any temperature. Acha, now you're going to use the same method for any other substance. So, for example, acha, so I'll just explain what you already just did. Any temperature that is between the two, the substance would be a liquid.
Yeah.
If the temperature is between the boiling point, lesser than the boiling point, and greater than the melting point, if it's between the two, the substance is going to be a liquid. If
Yeah.
it's above the boiling point, it's going to be in gaseous state,
Gas.
and if it's below the boiling point, it's going to be in
Solid.
solid state. Okay? So we're going to do the same thing to other substances as well.
Yeah.
So let's pick another example, which we are not familiar with. So we're going to use the same exact method. So once again. So another substance. Let's pick oxygen for a second. Now remember, all substances they exist in all three states, but it depends on at what temperature.
Yeah.
Now let's pick oxygen gas, and I'm making up these values. Oxygen has a
Okay.
boiling point of, let's say, minus 197 degrees centigrade, and it has a melting point of minus 241 degrees centigrade, right?
Okay.
So can you tell me what would be the state of oxygen at minus 50?
Wait. Doesn't that mean that the boiling point? Wait. Okay. Never mind. That's okay. Yeah. What you say? Sorry.
My question was, what would be the state of oxygen at minus 50? I gave you the melting and boiling points of oxygen.
Okay. Then it will be a solid.
At minus 50, right?
Yeah.
Did you try and apply the same logic that you did for water?
Yeah.
So let me show you. Achha,
Okay.
one thing. Oh, no, one thing. Let me just clear one thing first. Okay.
Wait. No. It will be. It will be. Actually. Yeah. Okay.
Then you can tell me what were you trying to say?
It'll be a gas.
Okay, exactly. It's going to be a gas. Achha, one thing about negative values. Remember that. Uh, when you have negative values, the bigger number is actually the smaller number. I mean, if you have minus 10, minus 5,
Yeah.
so which one is the
It's
smaller one?
a smaller one is -10.
Okay, so just remember that people sort of get confused when the values are, or when the temperatures are negative. Okay, so people get
Yeah.
confused with this. I mean, if you tell someone which one is the bigger number, they'll have to sort of think, because I mean this one is the bigger number, right? Minus 5 is
Yeah.
the so people kind of get confused when the values are negative. Okay, although they know how to
Yeah.
do that, but they still
Yeah.
get somewhat stuck at this. Acha,
Yeah.
so I'm going to show you how to use the same logic. I mean, you figure this out. The melting point is minus 241,
Mm.
and the boiling point in this case is minus 197.
Mm.
So what was the temperature that I asked? I said what was the state at minus 50. So
Yeah.
where would minus 50 lie? Would it be between the two?
It will be to the left of the melting point.
To the left of?
Sorry, to the right of the boiling point.
Exactly. So it's
Yeah.
actually bigger than the boiling point. Minus 50 is kind of
Yeah.
bigger than the boiling point.
Mm.
So now, quickly, just to try to confuse you more, what would be the state of minus 196?
It gotta be liquid.
Minus 196 is
Oh,
minus.
minus. Sorry, that's wrong. It'll be a gas.
It would be minus 196 is bigger than minus 197, right? So
Yeah.
it's going to be over here. It's going to be gas. Okay.
Yeah.
So remember, you're going to get confused with negative values. Okay. I mean, with water,
Yeah.
that was not an issue, but over here you're going to get confused. Okay.
Yeah.
So if somebody says minus 200, what would be the state of oxygen at minus 200?
Then it'll be liquid.
Okay. So it's going to be over here.
Yeah.
And what about minus 270?
then it will be a little solid.
ठीक है, so minus 270 is somewhere below minus 241, so it's going to be a solid.
Solid.
So you've got this right. You know how to do this. So I'm going to just
Yeah.
give you some work right now, and you have to predict the state of the substances, and you have to predict the state at. I'll give you three temperatures. You have to predict the state at minus 190.
Okay.
You have to predict the state at minus 50, and also predict the state at 200. And I'm going to pretty much make up the melting and boiling points myself.
Okay.
So for various substances, let's start with ammonia. There's a substance called ammonia, and its melting point. So this column would be, let me write it on top, the melting point and the boiling point. They're given. So this is, let's say, minus 57 degrees centigrade, and this is 17 degrees centigrade. Write down the states at all three temperatures.
So the minus 190 is gonna be solid,
Okay, so it's going to be a solid.
and then minus 50 is gonna be a liquid, and then 200 is gonna be a gas.
Okay, that's fine. Let's pick NaCl, which is your table salt. It's 98 degrees centigrade, and it's let's just make up these values. 880 degrees centigrade. So what's the state of NaCl at all three temperatures? At minus 190, what's the state at minus 190?
Minus 190 is a solid,
Okay.
and then at minus 50 is also solid, and then 200 is gonna be liquid.
Your voice just dropped. Did you lose?
At 200 is gonna be liquid, and at the other two is gonna be a gas. Sorry, solid.
Okay, so it's going to be solid. At the other two temperatures, it's solid. Okay, that's fine.
Yeah.
Uh, let's pick iron. It's 1300 degrees centigrade, and let's say 3500 degrees centigrade. So this,
They'd all be solids.
okay, in all states they would be solids. Just
Yeah.
1 minute. Give me 1 minute.
Okay.
अच्छा चलो ठीक है. So you've got this.
Hmm.
Then let's so we're done with boiling, and we're done with with boiling and evaporation in detail. Okay, so we know how to uh, figure out. Okay, so that's pretty much it. Boiling and evaporation.
Okay.
Let's continue with the next thing, which is kinetic particle theory. So once we are done with this, we're going to do a lot of past paper questions. Okay.
Okay.
So there would be a lot of practice questions after that.
Okay.
The next thing is, and that's related to kinetic particle theory. Do you know what Brownian motion is?
Yeah, it's a random motion of like particles in different substances.
They light particles.
No, atoms, right?
No, it's air molecules or air particles. So
Okay.
it's the. But let me.
Oh yeah, it's air particles. Cause yeah, okay, yeah. Because that's how
Asa,
the fusion is.
so basically, what they observed was that what they saw was that there were specks of dust,
Okay.
or it could be applied to any particles, and they were observing dust particles, and these dust particles were glowing when a light was when they were shining a light on it,
Yeah,
and
yeah.
you had these dust particles in a container,
Mm,
and what
mm,
they saw was that in the container, okay, let's say this is the container, the dust particles were moving haphazardly. Okay, they were moving in this direction, then they were moving in this direction, then they started moving in this direction, then they started moving in this direction.
yeah.
So Why were they moving haphazardly?
Because there was no forces acting on them. Because uh,
What was making them move? I mean, see, the dust particles moving in this direction first, right? And
yeah,
then all of a sudden it changed direction. Why did it decide to change direction all of a sudden?
because the air.
Exactly. So there were these tiny air molecules in the air that were
Then it would
bumping
hit and then bounce off.
and bounce off. So they were the ones that were actually making it go in. I mean, dust particles are really big. At a
Mm,
microscopic level, they're very big. So they were
yeah.
able to see the dust particles, but they were not able to see the air molecules. The air molecules are very, very tiny. So,
Mm,
so for them, it appeared that the dust particles were themselves just moving haphazardly, which was not true actually.
mm,
Air was the thing that was making them move in a haphazard manner. So this is what Brownian motion is. So whenever you have particles, for example, smoke particles in air,
mm,
the smoke particles would move haphazardly. They're not going to
mm,
go in one direction straight in a
mm,
straight line because they're going to
mm.
bump with air molecules. So specks of dust, they appear to move haphazardly and randomly. Why? Because they are constantly bumping. I said they are constantly bumping with air molecules. So you have lots of air molecules which are constantly bumping into them.
Okay.
And since let's not even call them molecules, let's call them air particles.
Okay.
So because we haven't studied atoms and molecules yet, so just call them particles with air particles. So
Okay.
constant collisions with air particles, and this haphazard movement is observed. Now, next thing, there's another thing which is called diffusion.
Yeah. Which is where air particles move from an area of high concentration to low concentration.
Okay, so this is again somewhat similar. Okay, they move from a region of you said higher concentration to a region of lower
Low concentration.
concentration. As so
Yeah.
particles, what kind of particles are they? Solids, liquids, or gases?
Gases.
What about liquids?
Oh yeah, and it can happen in liquids as well.
Okay, for example, if you put an ink drop
Yeah,
in water,
into water. Yeah, it will. Yeah.
what about solids? Can it happen in solids?
I don't think so.
See, I mean, it doesn't happen in solids. I mean, you have a
Yeah.
laptop. Okay, that's a solid. It
Yeah.
won't it won't just randomly fly
Yeah.
off.
Obviously. Okay. Yeah.
So the particles in a solid are stuck in their place. They can't move. The particles, so it's either liquids or gases. As a move from a region of higher concentration, so now a region of higher concentration, it simply means it's the place where there are lots of particles, right? The
Yeah.
region of higher concentration to a region of lower concentration. As I saw a region of higher concentration to a region of lower concentration due to random movements. Remember, we just talked about Brownian motion.
Yeah.
That particles are constantly colliding and they're randomly moving around. As I saw due to random movements. As I see examples, we'll do some examples.
Yeah.
Uh, liquids key, the example is ink in water. What's a real world example for gases?
Uh.
Well, there could be lots of examples.
Spraying deodorant in the room.
Right. So there's a You spray on one side and you immediately smell it on the other side.
Other, yeah.
So why do first thing, why does diffusion happen? Why? Because the particles are randomly moving around. They basically most of the time they're in Brownian motion.
Okay.
So if you spray perfume at one end, let's say I've
Mm,
sprayed a lot of perfume at one end,
mm,
how would the particles move? I mean, this is the region of higher concentration.
mm,
I
mm.
mean, they're going to
Th-
observe. Yeah.
they're gonna obviously move in brownie motion, but they're gonna move to the other corner and
ठीक है.
spread
I
out
mean,
as well.
right. I mean, particles don't really have a brain, ठीक है? So they're just going to move randomly in haphazard manner in different directions. For
Yeah,
example, think of this particle. This particle is traveling and it bumps into this side, and then it haphazardly bumps with air molecules, and it
yeah,
reaches some point. ठीक है? Randomly moves to another point.
yeah,
These other particles, they also travel and they randomly bump into air molecules and the sides of the container, and they reach another point. And slowly,
yeah.
what would happen? The particles
They
would
will
no
all they will all spread out,
they're all spread
be
out. ठीक है?
everywhere.
They'll be everywhere. So they're going to be just randomly be going in different directions. Some would be going in this direction. So all of them would eventually spread out.
Yeah,
And that's how particles. So basically, the idea isn't that they move from a region of lower concentration to a region of higher, sorry, a higher to lower. What they're basically doing is they're spreading out. Okay? They're
yeah,
not going to stay confined. So
yeah,
it's like you have things that are moving very fast, and you put them in one corner. Eventually, they're going to travel, and they're going to just occupy the whole thing.
yeah.
So, so that is what is happening. So it's
Okay.
random movement or Brownian motion.
Yeah,
So it's actually, even if there is no air, even if there is no air, the particles would still. I mean, they would travel in straight lines. For example, this particles over here. It's going to go. It's not colliding with anything, so it's not going to hit anything apart from the walls of the container. So it's going to bump into this wall. It's like billiard balls.
yeah. But how will it move though? Because what gives you the energy to move?
No, we are assuming that they are gases or liquids, so they already have the energy.
Okay.
ठीक है? So they're already in gaseous state, which means that they already are very energetic. Solids
Yeah,
can't do
yeah,
that.
okay. Yeah, that's why. Okay, yeah,
अच्छा, so except if there's no air, then there wouldn't be Brownian motion, but the particles would still spread out. I mean, they would travel straight lines, hit this container, so it's like billiard balls.
yeah.
Like
But it just won't be random.
so the movement would just not be random, but they would still spread out.
Yeah,
For example, if you look at the billiard table, it's the balls are at the center. If
yeah,
somebody hits it, they eventually spread out. Okay?
yeah.
So they're going to still spread out anyways, Brownian motion or no Brownian motion.
Mm.
Achha, so this is diffusion. Achha, now tell me, liquids or gases? Where would the diffusion be faster?
It will be quicker in gases because they have more energy.
ठीक है, gases are more energetic. So like the perfume, you spray perfume at one side, it immediately you can smell the perfume on the other side.
Yeah,
But if you put an ink drop in water, that's pretty slow.
yeah.
So gases diffuse faster compared to what? Compared to liquids, as they are more energetic.
Mm.
So diffusion is faster. So then you have other factors. Do you know of any factors that affect diffusion?
Uh, the wind, like the way the wind is going, temperature as well.
Okay, let's pick temperature for a second. So how does temperature affect?
If you have more temperature, then there's more energy in the molecules to cause them to move quicker.
Okay, higher temperature, more energetic.
Yeah,
Which means faster speed. ठीक है, so they travel faster. hence faster diffusion. So plenty of examples for this. For example, food, you can't really smell cold food. I mean, if you open the fridge, you can't really smell the food that's in the fridge because
Mm.
the particles are very cold. They won't be able to
Yeah,
travel to your nose very quickly.
yeah,
But at the same time, if you have a microwave or if you heat up the food, then the particles are
then
energetic and you're able to smell the food.
yeah,
Okay, so plenty of examples. Similarly, in summers, you can smell a lot of things. I mean, if there are flowers in the, you can even smell the grass.
yeah,
Uh, but in winters, pretty much you can't really smell flowers and
anything.
grass.
Yeah.
It's harder to smell things
Mm.
in winters. So higher temperature, more energetic, and hence faster diffusion.
Mm.
What about what's the other factor?
The direction of air, or the air current.
Okay, so let's call that wind.
Mm.
Okay, wind is one factor. More wind, and it depends on direction as well.
Yeah,
Because if it's blowing in the opposite direction, you won't be able to. For example, hunters they take a lot of care about direction of wind, so that
yeah.
the
So the animals cannot smell them.
animals cannot smell them. So
Yeah.
more wind depending on direction.
Okay, and also is it like the size, oh, the
What's the other
size
one?
of the size of the atmosphere, like the size of the thing in it. If it's smaller, they'll spread out quicker.
Okay, size of particles.
Yeah.
So that's an important point, and uh, that is smaller size, and it means faster diffusion. Smaller size means faster diffusion. Okay,
Yeah.
because they're going to travel faster. If an air molecule collides with them, so they're going to travel faster. Heavy particles not so fast. Okay, you can't really
Mm.
move heavy particles. You apply the same force on two objects. Uh, the heavy, it's a thing in physics. It's called inertia. Like heavy things, you apply the same force. They don't really like to move.
Yeah.
Small things, you apply the same force. They
They'll
like
move a lot more.
they move a lot.
Yeah.
So smaller size, faster diffusion. We're
Mm.
going to we're going to discuss this now. How do you know a particle has a small size or a heavy size? Now we're going to talk about molecules a bit. I said, remember,
Mm.
you don't know what molecules are. Okay? I mean, we're assuming still that you don't know what molecules are.
Yeah, kind of do.
Basically, so I'll just, no, I'm just assuming. Let's
Oh,
assume.
okay. All right. Okay. 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 Yeah. Yeah. Okay.
So molecule, any particle, it's made up of atoms, right? It's like NH3. This is ammonia. So how would you know the mass of this molecule? Because we have these formulas. What this formula tells you is that there's one nitrogen and there is three hydrogens in this particle,
Yeah. Which means
right?
it's four altogether.
Okay, so they're all combined together. How are they combined? We don't know, but let's assume okay, they are all combined together. See, there's one
Yeah.
nitrogen and three hydrogens.
Yeah.
So how do you find the mass? You open the periodic table. You open the periodic table. Let me just
And you
open,
look at the atomic mass.
and you look at the atomic mass. So you can either look at any periodic table, or you can look at the official periodic table. I think. Wait one second. Let me send you this link as well. Wait a second. Where's your syllabus? This is the marking scheme. Just one second. This one, I think. Let me send you the official periodic table. But where's the syllabus? Just one second. I said this is download specifications. I said I'll send you the link. I
Okay.
said not just the link. Let me first find the periodic table. This is your uh, periodic table. 109 page, 109 page. There's 109. You can either Google this, but there are lots of periodic tables. But I think you should
Yeah.
this one out. So
Okay.
how do you rotate this name? Is 109. Okay, let me quickly. If for some reason it goes back to 109. 1 second. And just so I can't rotate it. But this is the periodic table, so you have to sort of look at it sideways.
Yeah.
Uh,
Okay.
this is your official periodic table, and let me send you the link of this. This is just one page. I think you should print this exact periodic table.
All right.
Uh, this 1 second. Okay, this is the link. I've sent you the link. You can print it later. Okay. Copy the link
Okay.
because if the class disconnects, you can copy it and paste it somewhere. I said this is the
Okay.
official periodic table, and you already know that you have to use atomic mass. Okay, I'm stressing on the official periodic table because different periodic tables, the representation is different. They present the
Yeah.
data
Okay.
differently. So stick
Okay.
with the ones that you're going to use. Uh, so if you can sort of tilt your head, the number at the top, they've given you a key. The number at the
Mhm.
top is the atomic mass.
Yeah.
So we were talking about NH3. Where is nitrogen? And where is hydrogen is over here,
Yeah. The top one. It has a atomic mass of one.
and nitrogen is
Number four. It has 14.
okay, so
Atomic
it's
mass is 14.
14. So you go back and you figure that out. Nitrogen is 14
Mm.
and hydrogen is one. But there are how many hydrogens? There are three
Three.
hydrogens.
So it'd be 14 and 3 would be 17.
So it's 17. So you can figure out the mass of a lot of substances. So there's
Yeah.
try and find the mass of these substances. Carbon dioxide. TK, tell me what the mass of this carbon dioxide particle is.
Wait, one second. I need to see the periodic table first.
Also, you can open the periodic table, page 109.
Yeah, I'm going to. Okay. So what was it again? Uh, okay. So CO2.
Yeah, CO2.
So that would be 40, 46, wait, 44,
44, yes.
and then there's H2O, and it's gonna be 18 H2O.
TK, so that's 18.
Yeah. Is that hydrochlorine?
This is hydrogen and chlorine.
Okay,
It's called hydrochloric hydrogen chloride. Well, let's
just
split it.
hydrochloric acid, right?
But it has two names, hydrochloric acid, and it's also called hydrogen chloride.
Okay, this will be 30, 36.5.
Okay, so it's 36.5. And let's pick a slightly bigger molecule. It's CH3COOH.
So CHCOOH again. CH3, so 15, 15 15, 37, 38, 88, and 68, 60, 70.
70, are you sure?
I think so. I'm not gonna calculate. I'm not sure. Okay, let me
Just
expose.
they just do it mentally. Yeah? It's carbon, two carbons, that's 12 plus 12, that's 24.
This, yeah,
Plus the two oxygens, so that's 16 plus 16, 32.
yeah,
What happens if you add what 32 plus 24? That's
50,
50.
60,
It's 24 plus 32, 56.
20. Oh, okay, sorry. Yeah, 56.
You want to 24 plus 32, that is 56. Okay?
Yeah, yeah, it is. Yeah, sorry. I heard you wrong, I think.
And then there are four hydrogens.
Which is 4. So that's 40.
60.
60. Oh,
Well, it's basically 24 plus 32 plus 4, right?
okay. I heard you wrong on the numbers.
Okay, so that's 60.
Yeah,
ठीक है चलो ठीक है Afif, just revise this, ठीक है, all of it,
okay,
whatever you've studied. I might but tomorrow you're probably going to have either biology or physics. So I'll
okay,
give you. So we're going to have class next week now, Monday, Tuesday, right? So
okay,
so I'm going to give you some work. ठीक है, I'll message you,
okay,
and you can sort of complete it and then submit it. It would be related to this.
okay.
ठीक है. So tomorrow you'll have your bio class.
Okay.
ठीक है. Any questions about this?
No, it's okay.
चलो ठीक है. चले. Okay Afif, take care.
Okay. Okay, I love this.
Allah Hafiz.
Wait, one second, one second, one second, one second. Hello, hello.
Yes.
I think my dad needs to talk to you about something.
Okay.
हेलो फहद, आवाज आ रही मेरी?
जी आवाज आ रही
जी,
है.
कैसे हैं आप?
मैं ठीक ठाक.
अच्छा, तो फिर ठीक है, इसका ये वाला टाइम कंटिन्यू.
हाँ, ये वाला टाइम तो ठीक है. वो बस
ठीक है.
नंबर ऑफ क्लासेस जो थी ना, वो मैंने कंफर्म करनी थी कि क्या है ना, क्योंकि वो वैसे तो पहले तो वो बात हुई थी ना कि वो तो 3 क्लासेस पर डे बन रहा था ना.
हाँ जी, हाँ जी, बिल्कुल बिल्कुल. या
लेकिन अब मेरी अंडरस्टैंडिंग है कि वो 2 क्लासेस केमिस्ट्री की होंगी पर वीक,
2 बायोलॉजी की,
2 बायोलॉजी और 2 फिजिक्स.
नहीं वो अभी फिजिक्स की तरफ नहीं आ रहा. वो कह रहा है कि मैं 2 सब्जेक्ट से स्टार्ट करूंगा.
अच्छा
एंड
ठीक है.
एंड ऑफ सितंबर फिर मैं देखूंगा कि इफ आई कैन कोप अप विद द थर्ड वन और नॉट.
ठीक है.
तो
फिर अच्छा, फिर वो इसमें फिर वो इंडिविजुअल वाला ही ना.
हाँ जी, नो प्रॉब्लम. आई थिंक दैट सूट्स हिम.
हाँ, क्योंकि वो फिर ये अब इसके लिए टेलर मेड है ना, ये 2
हाँ जी,
क्लासेस.
नो प्रॉब्लम.
अच्छा, इसमें वो देख लें कि कोई और स्टूडेंट तो नहीं है आपके पास AQA
हाँ
में.
जी, हम पूछ रहे हैं. अभी तक तो किसी ने विलिंगनेस नहीं शो की. अगर होएगी तो वी विल
अच्छा, वो जरूर. हाँ चले ठीक है.
तो बायोलॉजी वाला कब बताएंगे, कब शुरू करेंगे आप इसका?
नहीं, कल कर लेंगे. कल 10. अच्छा नहीं, कल 9 o'clock हो सकती है.
9 o'clock का मतलब है यहाँ पे 5 o'clock होंगे. हाँ, हो सकती है.
बस ठीक है, 9 या 10 इन दो में से है टाइम, वो मैं कंफर्म करके आपको बता देता हूँ.
चले. और उसका टीचर का नाम
ये है
वही है जो?
नहीं, मैम नाजिया है.
ठीक है.
तो
ठीक है.
वो यहाँ पे हेड स्टार्ट में होती है टीचर, इस्लामाबाद में.
ठीक है. ठीक है.
तो वो मेरे साथ पढ़ाती है बायो.
ठीक है.
तो उनकी क्लास अटेंड करके देख ले.
ठीक है. एब्सोल्युटली फाइन.
चले ठीक है.
तो सी यू टुमारो. नहीं, अब टुमारो फिर अब क्या करेंगे हम? टुमारो अभी इसकी केमिस्ट्री की भी हमने लेनी है मजीद, या?
नहीं, 2 क्लासेस होगी ना केमिस्ट्री की. तो
हाँ, तो
बायो
अब ठीक है, बायोलॉजी होगी.
अब अगले वीक मंडे ट्यूसडे बेसिकली वो होगा, केमिस्ट्री होगा.
ठीक है.
ठीक है.
मंडे ट्यूसडे केमिस्ट्री, और फिर आप बायोलॉजी का कंफर्म कर देंगे कल से या जब
हाँ
से भी एएसएपी.
हाँ, बस कंफर्म समझ ले वो. उसका कर लूँ मैं, बस टाइम का मैं आपको बता देता हूँ एग्जैक्ट.
थैंक यू वेरी मच फहद.
चले ठीक है. ओके देन.
थैंक्स अ लॉट. अल्लाह
ठीक है, अल्लाह हाफिज।